Good morning to all. I am Dr. Sourabh Sharma, working as Associate Professor in School of Engineering at Avantika University, Ujjain. Today I welcome you in my video lecture on to Soft Computing. These are the contents which I will cover today in my presentation. First, we will see what is the concept of computing, the characteristics of computing, what is the basic difference between the soft computing and the hard computing, soft computing and its techniques. Then we will see what are the applications of the soft computing. Then we proceed with the characteristics of soft computing. And finally, we will see what are the hybrid computing, that is the mixture of the soft and the hard computing. So we will start basically with the concept of computing. So what is computing? Computing is nothing but we are giving some input to the processing unit which is doing some computation on that input unit and produce some output. Now this computing can be anything. It can be a mapping function or it can be a mathematical function which is doing the calculations according to the input which we have set, and accordingly the output has been generated. So this is the basic concept between of the computing. So here the function or the mapping function is nothing but a formal method or an algorithm which is used to solve any particular problem for which we have given the input variables. Some of the important characteristics of computing. The computing will always provide the precise solution, means whenever we are doing any computation, the exact output should be obtained by that computing method. The control action or the mathematical function or the mapping function which we have seen in the previous slide will be unambiguous in nature and it should be accurate in nature so that it can provide the precise solution. It also suitable for problems which is easy to model mathematically. Okay, so before starting with the soft computing, first we will see what is hard computing. So in the year 1996, the scientist named as Lofty-Zadeh has introduced this term which is known as the hard computing. So according to the hard computing, the characteristics of the hard computing are it always provide the precise solution. The control action or the mapping function which we are using for the mathematical expression is unambiguous in nature, and the control action is formally defined, means a mathematical model is always there which is doing this computation. So some of the examples of the hard computing include the solving problems like if we are calculating the roots of the polynomial equation, if we are doing the integration or the differentiation, then always we are using the precise or the accurate method for calculating these. Other examples include searching and the sorting techniques. Other examples like the computational geometry, like if we are computing the shortest path in the graph theory or finding the closest pair of points. So these all methods require the exact mathematical model and they should be unambiguous in nature, otherwise the result which they produce is not precise. So what is soft computing? So soft computing is one of the emerging approach which is recently introduced by the same scientist known as Zadeh. So the soft computing is tolerant to imprecision, uncertainty, partial truth and the approximation to achieve the tractability, robustness and the low cost solution. So the foundation which we find in the hard computing, that foundation can be overcome by using the soft computing approaches, because here we are having the tolerant to imprecision to the result which we are getting from doing the computation. There should be uncertainty or the partial truth is there which is similar to the human being behavior. So if we want some output from the human being, that same can be obtained if we apply the concept of soft computing. So some of the characteristics of the soft computing. So it does not require any mathematical model for problem solving. So as in contrary to the hard computing where we have seen that we require the exact mathematical model for solving any problem, but in soft computing it doesn't require any specific mathematical modeling for solving the problem. The soft computing may not yield the precise solution. The meaning of this is that the soft computing approach doesn't guarantee to provide you the exact or the precise solution for the problem. It always provides you the approximate solution, or we say it as a nearby solution. Algorithms which we used in the soft computing are adaptive in nature. That is the reason why we are not getting the precise solution, that why we are getting the approximate solution, because the algorithms which we generally used in the computation in soft computing, they are adaptive in nature. They adapt according to the input and the environment on which they are working. And it use some biological inspired methodologies for solving the problems, which includes the genetic algorithms and the other nature inspired optimization algorithms like the evolutionary algorithms, the ant colony optimization algorithm, particle swarming, and human nervous systems. Okay, so these are some of the soft computing approaches which we generally used for calculating the precise solution. Now, as we proceed further, so the components which we use or the approaches which we use in the soft computing include the fuzzy set theory, which is generally based on the uncertainty principle, the neural networks, or we say it as an artificial neural network, which is replicating the human brain, in which we are using the learning and the adaptation according to the environment and to the problem. Then next is the probabilistic reasoning. So we have seen a lot of probabilistic reasoning algorithms are there, which generally works on the probability for finding the precise solution. So here we are use reasoning in uncertainty. And finally, we are using the evolutionary computing, which is adaptive in nature and using the optimization algorithms. So these are the 4 components which generally cover the soft computing approaches. The development history of the soft computing includes, so it is basically the mixture of the evolutionary algorithm, which is introduced by a scientist known as Reichenberg in 1960, and the neural networks, which is introduced by McLeod in 1943, and the fuzzy logic, which is introduced by the Zadeh. Okay, and these evolutionary algorithms consist of different probabilistic and the optimization algorithms like the genetic algorithms and other nature-inspired algorithms. So this is the development history, how the soft computing approaches has been introduced. So we will begin with the first approach of the soft computing, that is the fuzzy logic, which is based on the uncertainty principle. So fuzzy logic is a mathematical language to express something. This means it has the grammar, syntax, semantic like a language for the communication. Okay, so it is one of the specific mathematical model which use the set theory for doing the computation. So there are some other mathematical languages are also in exist, which is the relational algebra, Boolean algebra, and the predicate logic. The fuzzy logic deals with the fuzzy sets. So as the name suggests, fuzzy, the fuzzy means which is not exact. Okay, so its contrary is the crisp set, which is the exact. So when we are using the fuzzy logic for solving any particular problem, so first we have to convert that input values into the fuzzy set. So we will see now what is the logic behind the fuzzy logic. So fuzzy set is an extension of the convention or the crisp set, okay, by presenting the notion of degree of membership of an element in a set. Okay, so as I've told that in the fuzzy logic, instead of using the crisp values or the exact mathematical values, we will use the fuzzy sets, which generally consist of the membership values, which is assigned to that particular value on the basis of probability. So fuzzy logic is a precise logic of imprecision and approximate reasoning. So if we are having a problem for which we are able to tolerate the imprecision of the result and the reasoning, then we prefer this fuzzy logic for solving that particular problem. So fuzzy logic is having the capability to converse, reason and make rational decision in an environment of imperfect information, and it is also having the capability to perform a wide variety of physical and the mental tasks without any measurements and the computations. So this is the basic architecture of the fuzzy logic, that how the fuzzy logic concept has been implemented. So as we can see in this slide, we are having the input values. Okay, so first we have to convert these input values into the fuzzy sets. using the fuzzy elements. Okay, and after converting the input values into the fuzzy sets, we will apply the fuzzy rule over that for doing the computation, and that fuzzy rules will describe that what implications we are using, like if, then, else, or the other fuzzy implication for solving that particular problem. And then finally we will get an output, which is the output in the form of the crisp set. So this is let us understand the concept of fuzzy logic with an example. So here in this slide we can see that a robot is there and there is a path, and in between that path so many hurdles are there. So as we can see in this slide, the red dots are representing what? The hurdles, and the robot is there which he wants to move from source to the destination. So if we suppose this is the source and this is the destination, and in between there are so many red colored dots, which is the hurdles. So there is no straight path which this robot can use and reach to the destination. So he has to select a path which is shortest and which is easily feasible for him. So that can be implemented with the help of fuzzy logic, where we generally use the membership values, which is derived on the probability that, as we can see that there are multiple paths possible. Okay, but we have to select that path which is feasible and nearest from source to destination. So here we can use the concept of the fuzzy logic to find the suitable path. So we have seen the first concept of the soft computing, that is the fuzzy logic. Now next we will see the next approach of the most common approach of the soft computing, that is the neural networks. Okay, and this neural network we also named it as artificial neural networks, because it resembles to the neurons which is present in our human brain. It works in similar to the human brain neurons. Okay, so that is why we named it as artificial neural networks. So what it is? A computing system made up of number of simple, highly interconnected processing elements, that is the neurons. So it processes information by their dynamic state response to the external input. Okay, so we acronym artificial neural network as ANN in our further slides. So ANN is used to solve problems involving the non-linearity, especially the pattern recognition, classification, and the clustering problems. Okay, so basically for what kind of problems we generally use the artificial neural network? So the problems which are non-linear in nature, especially the pattern recognition, classification, or the other clustering problems. So the main application of these neural networks we will find in the machine learning. Why? Because it is capable of learning through adaptation of the new inputs. So this is the analogy between the human brain and the artificial neural network. So the first part in this slide representing the biological neural network, which we acronym as BNN. So, and the second diagram in this slide is representing the artificial neural network. So in this slide, we have tried to explain that how the human brain is resemble with the artificial neural networks. So as in the human brain, we are having the dendrites, which is responsible for transformation of information from one neuron to other neuron. Okay, so in between that we are having the nucleus, and it is covered by the cell body. Okay, and these one dendrites are interconnected to other dendrites with the help of the axon. So on the basis of that, the artificial neural networks are introduced. Okay, so the input variables, as we can see in the biological neural networks, are getting from the dendrites. So in a similar fashion, we are having the input values which we want to give to our model. Okay, and we will assign certain weight values to that. Okay, and after that, as we are having the cell body, so we are having some summation function here, which generally sum the input values and the weight values after doing certain computation. Okay, and this summation will be given to certain threshold limit, that which particular neuron has to be hit so that its action has to be performed in the form of the output. Okay, so why we are choosing the weight values here? Because we have no control over the input values. We are having only control over the weight values, which we can change. Okay, so as we proceed further, we will see that different kinds of artificial neural networks are there, and if we want to change the outcome of that particular neural network, then we generally use to change the weight values which we are assigning to the each input, so that we can able to get the desired output. Okay. So basically this slide represent what, that how the human brain is analogy to the artificial neural networks. So as I have told you that there are different architectures of neural networks are there. So this slide is describing that how many different types of artificial neural network architectures are there. So we are having the single layer feed forward architecture, multi-layer feed forward architecture, and the recurrent network architectures. Okay. So this slide is giving some light on the single layer feed forward neural networks. Okay, so as we can see that there is a single layer which is in between the input and the output. Okay, so we are having the single layer. So in the input layer we are giving the input values and we are assigning certain weight values to it. So after doing the computation of that, we will proceed it to the middle layer, which is our input layer. Okay, and after doing the computation by giving certain threshold values and the summation values over here, we will assign the respective output values. Okay, so this architecture represents the single layer feed forward neural network. Feed forward here represent that we are moving only in a single direction, that is in the from left to right. Okay, because we are not doing any computation from right to left. That is the reason why this architecture is feed forward in nature. Now the next architecture which is there for the artificial neural network is the multi-layered feed forward neural networks. Okay, so if we see this architecture, we will find that multiple layers are there between the input unit and the output unit. Okay, and why we have done so? Because if we are not able to get the exact solution or the precise solution from the single layer feed forward neural networks, then we try to increase the number of middle layers so that the more computation and the error should be decreased. Okay, so this architecture is representing that we are having some input values, and for doing the computation we are having the multiple middle layers which is doing the computation and providing the desired output at the output unit. Next is the recurrent neural network. So till in the last two architectures we have seen that we are having only the feed forward concept. Okay, and we are not having any kind of feedback to the previous layers. Okay, so this recurrent neural network is that it depending on different types of feedback loops. Several recurrent networks are known in existence, like the Hopfield network is there, or the Boltzmann machine network are there. Okay, so these are some of the examples of the recurrent neural network in which we are having the facility to give the feedback to the previous layer. And what is the importance of this feedback? So that they can update their weights and we can obtain the desired output which we want from our input values. Okay, so let's understand this concept of artificial neural network with the help of an example. So this example is the human character recognition example. Okay, so suppose we are working on some form and we have to recognize the alphabet which is written by the humans. Okay, so we are having some computation unit which is recognizing this input values. So in this we have written the Hindi character, that is A, and this way of writing this A can be depends on the handwriting of the user. Okay, so as we can see that different people have written the character A in a different manner. Okay, so this soft computing or the artificial neural network task is to correctly recognize that which letter the user has written. Okay, so on the basis of using the input values, the weight values, and the summation unit and the threshold value, it correctly recognize the A. So this example is of handwritten character recognition using the artificial neural networks. Okay. Now next is what the evolutionary approaches, which is the main approaches of the soft computing. So evolutionary computation uses the computational model to of evolutionary process as key elements in the design and implementation of computer-based systems and problem-solving application. Okay, so the evolutionary computing is generally based on the concept of evolution of or the number of iterations which we used for computing the probabilistic solution of our problem. So there is a wide variety of evolutionary computational models which are available for doing the for solving the different engineering problems. So they share a common conceptual base of simulating the evolution of individual structures via process of selection and the reproduction, which is the main concept of the genetic algorithms, which is also there in the human being. So they depend on the performance, which is known as the fitness of the individual structure for choosing the best output. So evolutionary algorithm, most precisely we can say that evolutionary algorithms maintain a population of structures. So population of structures means here represents the input variables. Okay, so that evolve according to rule of selection and other operators such as the recombination and the mutation. So in the evolutionary algorithms, basically what happened, we are having the input set which we named as a population. Okay, so this population consists of the solution which we are searching for, but we are searching for the optimal solution. Okay, and how or what are the methods of selection of that optimal solution, that is based on the evolutionary algorithm which we are using. So if we are using the genetic algorithm, then there is certain steps as we have seen, the mutation and the crossover, okay, which selects the best individual or the best solution among the population using the fitness value of that particular individual. So each individual in the population receives a measure of its fitness in the environment. The selection focus attention on high fitness individuals, thus exploiting the available fitness information value. Okay, so it is similar to the process of selection of something. We can understand this concept of evolutionary algorithms with the process which we generally use in the campus selection of the students. So when a student sit in the campus placement, so what will happen? There are number of students which are sitting or which are fighting for the selection. Okay, the selection is based on the concept of their fitness. Now their fitness can be calculated either on the basis of soft skills or the communication skills or the technical skills. Okay, so these are what some of the parameters which we generally use. So similarly in the genetic algorithms, we use the crossover and the mutation for the selection of the best individuals so that it can be selected for the to optimize the results. So this is the basic architecture of the genetic algorithm. Okay, so in this architecture we can see that first we have to initialize the size of the population, that what input size we are taking for finding out the optimal solution from that group of individuals. Okay, so first we should initialize the population. We have to define the parameters, parameter representation, and we have to create the population size. Okay, then we move to the converge. Okay, and if we are not moving to the converge, then we evaluate the fitness of that individual. Okay, then we applied the selection process. Okay, we will select the best mate from the individuals on the basis of the fitness values. Okay, so fitness values has been computed with the help of some mathematical functions which is based on the objective function for which we are selecting the individuals, and the individuals which produce the best fitness values that has been selected in this selection mode, and it will be moved to the reproduction section. So in the reproduction section we are having three things: the crossover, mutation and the inversion. Okay, so once the best individual pass through these reproduction process, and if it is not able to guarantee that we are getting the converge to the optimal solution, then again we will move the same process. But if we get the best optimal solution, then we stop and we will obtain the final optimal solution. Okay, so this is the schematic diagram which is representing the concept of the genetic algorithm, which is very similar to the genetic algorithm in the human beings. So now let us understand this concept of evolutionary algorithm with the help of some real world example. Okay, so in this slide we have seen that there is money allocation problem. So money allocation problem is what? A person is having the money and he want to invest in certain different sectors so that he can able to earn maximum return from it. Okay, so he is having a lot of options. If he want to invest his money in the banks, so in the banks also they are having multiple banks. Okay, and in the multiple banks they are having the multiple investment policies. Now the problem with the man is that he has to invest in which bank and in which policy. So that can be computed with the help of this evolutionary or the probabilistic based algorithms, which able to invest the money of a person in such a way so that he can earn the maximum return from it. Okay, so this problem of selection of which investment policy or which bank, that is handled by this evolutionary algorithm, and this evolutionary algorithm is doing that only on the basis of the best individual. Means the best individual means that which particular bank he has to select and which particular scheme he has to select. So instead of putting all this burden on the human being, this soft computing approach will solve that problem so that a person can get the maximum return from that thing. Okay, so it's the same thing we can see by the current world example like the policy bazaars and the other things, which is doing the same thing on the basis of the evolutionary algorithms. They are predicting that which stock is better for that particular person so that he can invest in that and can earn the maximum return from that. So this is one of the real world examples of the evolutionary computing. So now let us understand this how soft computing works. Okay, so we can understand that how soft computing works with an example of a classroom. The classroom consists of the teachers and the students. Okay, so how a student learn from his teacher. Okay, so teacher will ask certain questions and tell the answers to the student. Okay, when he is in teaching to their students, teacher put certain questions and maybe he will put certain hints to so that hints over the answer so that a student can able to answer the questions. Okay, and the teacher will predict that whether that answer given by the student is correct or not. Okay, so the student does learn a topic from a teacher and store whatever he has learned from in his memory or in his brain so that he can answer a different questions which is related to that question in the whenever a particular question has been raised in front of him. Okay, so based on the knowledge he solves a new problem. Okay, and this is the way how the human brain works. Okay, so in the soft computing approaches we try to make this human brain workings on the machine also. Okay, so because everything the human brain cannot do. Okay, so if we want certain answers from the machine, then we can train the machines by using these soft computing approaches. Okay, so based on this concept, the artificial neural network is used to solve the problems. Now, what are the advantages of the soft computing? So as we have seen that different approaches we are using, and we have seen that different examples that how the real world examples are solved with the help of these soft computing approaches. So there are a lot of advantages of using the soft computing. So it made solving non-linear problems very easy. Okay, in which we require the mathematical models, and for solving these non-linear problems where the exact mathematical models are not available. It introduced the human knowledge such as the cognition, recognition, understanding, learning and others in the field of computing. Soft computing provides an opportunity to represent ambiguity in human thinking with the uncertainty in real life. Soft computing methods are non-linear in nature and can approximate complex non-linear and the dynamic systems. And finally, it will provide the approximate reasoning. Okay, so these are some of the advantages which is not there in the hard computing approaches, because there we have to use the exact mathematical model. The steps which we have to follow has to be very accurate, and we cannot change our steps or the iteration on the basis of the input. Okay, so these soft computing approaches provide that feasibility to us that we can adapt according to the environment so that we can get the approximate results. So these are some of the advantages of the soft computing. Now next we will see that what are the application areas where we can use these soft computing approaches. So as there are a lot of applications available in where we are using these soft computing approaches, so it includes the heavy industries, the home appliances, the automobile sections, spacecrafts, business, finance, robotics, medicine, behavioral sciences. So as we can see, the soft computing approaches are very helpful nowadays, and it's having application in every field. Now let us understand that using other applications, that how this soft computing has been used. So handwritten script recognition, as we have seen the previously also in one of the examples, that how this handwritten character can be recognized using the artificial neural networks. Okay, so it is representing what? It is representing the same, and it is representing some of the insights which we used for the human character recognition or the human script recognition. So human script recognition is one of the demanding part of the computer science. It can translate multilingual documents and sort the various scripts accordingly. It uses the concept of block label technique, where the system recognizes the particular script from a number of script documents. And if we go inside in it, we use certain transforms which include the discrete cosine transforms, where we will convert our signals into the AC and the DC components, and the discrete wavelet transforms, where the input signals are converted into the multiple signals, include the approximate, horizontal, vertical, and the diagonal elements, which classify the scripts according to their features. Other applications include the image processing and the data compression using the soft computing. Okay, so as we have seen, after the digitization or the concept of our Honorable Prime Minister Narendra Modi, the digital India, everything has been digitized. Okay, so this can become possible only with the help of image processing. So we can use the soft computing approaches in image processing and data compression also. So image analysis is one of the most important part of the medical field. It is a high-level processing techniques which include the recognition and bifurcation of the patterns, which we generally use in the medical diagnosis. So using soft computing, we solve the problem of computation complexity and efficiency in the classification. Techniques of soft computing, as we can see, we are having the genetic algorithms, classifier systems, neural networks, fuzzy logic. Okay, so that we can solve some of the real world problems in which the concept of image processing are used. These algorithms give the fastest solution to the pattern recognition. These help in analyzing the medical images obtained from microscopes as well as to examine the X-rays. Okay, so these soft computing approaches can be used in the field of the medical diagnosis also, for prediction of the diseases, and we also used for the data compression. As we can see, everything can be available on the internet, or it can be moved from one place to other place. So the concept of data compression is also important nowadays, because the data generally consists of lot of amount of memory, and if we want to compress that data, then we can use the different soft computing approaches also for representing the same. Now next is use of soft computing in the automobile systems and manufacturing. So these soft computing approaches are not restricted only in the computer science fields. It is applicable on all engineering applications, includes the automobile industries also and the manufacturing. So the use of soft computing has solved a major misconception that the automobile industry is slow to adapt. No, by the introduction of these soft computing approaches in the automobile sector also, it can adapt according to the nature or the environment, and the speed of processing will increase. So fuzzy logic is a technique which is generally used in vehicles to build classical control methods. So as we can see, we are having the self-driving cars. So these self-driving cars are using the concept of fuzzy logic for the driving mechanism. It takes the example of human behavior, which is described in the form of rule, if-then statements, which we generally use in the fuzzy logic, the logic controller that converts. So in the fuzzy logic, when we use in the automobile systems, it generally use certain sensors and the controllers for doing all these computation. So as we have seen, a lot of application of the soft computing, including the predictions or in the medical diagnosis or in the image processing. Okay, next we will see it is not restricted to the computer science or the automobile industry. It is also this soft computing approach can also be used for the infrastructure architecture. So an intelligent building takes input from sensors and the controllers effects by using them. Okay, so when we are building any new building or we are creating the infrastructure architecture, so in that also we can use the soft computing approach. So the construction industry uses the technique of distributed artificial intelligence and fuzzy genetic agents or the fuzzy genetic algorithms to provide the building with capabilities that match the human intelligence. The fuzzy logic is used to create behavior-based architecture in intelligent buildings to deal with the unpredictable nature of the environment, and these agents embed sensory information in the building. Okay, so on the basis of soft computing approaches, the infrastructure architecture is also built so that if any natural calamity occurs, that building can handle that natural calamities, which includes the earthquake or the other calamities which generally occurs by the nature. Soft computing and the decision support system. So as we have seen that if we are having any problem where we have to take certain decision on the basis of certain parameters, so at that time the human brain can take decision only on the basis of their experience or the knowledge of that particular domain. Okay, so the soft computing can provide you the use of decision support system also to provide the decisions. So the soft computing gives an advantage of reducing the cost of decision support system. The technique are used to design, maintain and maximize the value of the decision process. The first application of fuzzy logic is to create a decision system that can predict any sort of risk in any particular thing. The second application is using fuzzy information that selects the area which need replacement. Okay, so these are some of the examples where the soft computing approaches can also be used where the decision has to be taken on the basis of certain parameters. Now next is what the soft computing technique in the power system analysis. So the soft computing uses the concept of artificial neural networks to predict any instability in the voltage of the power system or not. Okay, so suppose if we are having an infrastructure and in that infrastructure we are applying the power system so that it can operate, or we are having any organization where the concept of power has been used, so we can use the approach of soft computing, that is the artificial neural network, to maintain the instability in the voltage of the power system. So using the artificial neural network, the pending voltage instability can be predicted. The methods which are deployed here are very low in cost in comparison to the human analysis, because if we put the same or if we do the same thing by using the human, then the chance of error are more in terms of human. But if it is operated by some machine and which is having all the control of the power system, then it can able to work properly. So for this we use the concept of artificial neural network to maintain the instability in the power system also. Soft computing techniques in bioinformatics. So it is this soft computing approach can be used in the bioinformatics field also. The technique of soft computing helps in modifying any uncertainty and indifference that biometrics data may have. Soft computing is a technique that provides distinct low-cost solution with the help of algorithms, database, fuzzy sets and the artificial neural networks. These techniques are best suited to give quality results in an efficient manner. We can use soft computing in investment and trading. We have seen the example that how a human can invest his money and can earn maximum return from it. Now we have seen a lot about the soft computing, and finally we come to make the difference or the comparison between the hard computing and the soft computing approaches. So in hard computing, it requires a precisely stated analytical model and often a lot of computation time for doing the computation. In reference to that, soft computing is tolerant of imprecision, uncertainty, partial truth, and the approximation. In the hard computing is based on the binary logic or the CRISP system or the numerical analysis, where we generally use the exact softwares for doing the computation. And in soft computing, as we know, it is based on the fuzzy concept, neural networks, and the probabilistic reasoning. So here we doesn't require the CRISP softwares, but they are adaptive in nature, which can adapt according to the environment. Next, in hard computing, it is having the characteristics of precision and categoricity, which is not there in the soft computing. So in the soft computing, it is having the approximation and the dispositionality. Next is in the hard computing, it requires a precisely stated and analytical model and often a lot of computation time for doing the computation. And the soft computing is doing the same thing in a lesser amount of time period. Okay. Hard computing is based on exact mathematical model, but the soft computing is based on the fuzzy logic, neural net, and the probabilistic reasoning. Okay. So these are some of the differences between the hard and the soft computing. Now next we will see at the end that there are certain hybrid systems also, which generally use the concept of both or the hybridization of the hard computing and the soft computing. Okay, so it is totally depends on the application where we are using that particular hybridization if it is required. So it is in the hybrid computing, it is a combination of the conventional hard and the soft computing. Okay, so as we can see in this diagram that we are having some hard computing approaches and we are having certain soft computing approaches, and we have to design a method which is hybrid of both. Hybrid of both means it may use certain hard computing thing and certain soft computing things, so that the solution of that particular problem which we have given has been obtained. One of the example of the hybrid technique is the neuro-fuzzy computing. Okay, so it is the mixture of the neural networks and the fuzzy logic. Okay, so this is a system in which two or more methods are integrated. As we know in the hybridization, instead of using a single soft computing approach, we can use the hybrid approach, which is a mixture of one or two different methods, so as to overcome the limitation of the individual techniques, because it may happen that any particular soft computing approach is having certain limitations. So if we want to overcome that limitations, we are having this facility to hybrid two or different soft computing approaches and try to design a different hybrid system. So NFC, that is the neuro-fuzzy computing, was developed to model the following capabilities: development of a biological neuron which is inspired from the fuzzy neuron, inclusion of fuzziness into a neural network, and development of a new learning algorithm for the neuro-fuzzy computing. Okay, so this is one of the hybrid architecture which we can create. On the basis of hybridization, we can use the multiple approaches for solving our problem. Okay, and finally we will see that what are the recent developments in the soft computing approaches. So people or the users have started using the techniques of soft computing like the fuzzy theory, neural networks, fuzzy neuro system, adaptive neuro-fuzzy system, which we name as ANFIS, for driving various numerical simulation analysis. Soft computing has helped in modeling the process of machine with the help of artificial intelligence, which is very common nowadays. we can see how the chat GPT has solved all the problems of a user within a minutes. So all this can be possible with the help of machine learning, AI and the soft computing approaches. Also, there are certain areas where soft computing is in budding stages only, and it is expected to see a massive evolution, which includes the big data or the recommender system, behavior and decision science, mechanical engineering, computer engineering, civil engineering, and all the different engineering aspects. Okay. So thank you for listening me. That's all about the soft computing and introduction of the soft computing approaches. Thank you.